Is she? Okay, is she going to do a sentence correction for you? Okay. All righty. Sure if I'm recording. All right, mercy. All righty, so talk about writing some equations, and then we're going to kind of go over balancing today. All right. Feeling like. All right, so we've talked about chemical reactions before, and they can be represented by a chemical equation, and that's what we're looking at, anytime a chemical change. And so we're going to look at the components of the equation. So just to remind you, it starts with the reactants, and it goes to the products in a chemical equation. So the equation must contain the correct formula for the reactants, and those would be on the right side. No, not the right side. Sorry, y'all. How about the left side? Of the arrow. That would be my reactants, what I start with, and then my products would be on the right side of the arrow. So start with your reactants, they undergo some kind of chemical change, and you end up with your products. The law of conservation of mass and energy, we're not so much worried about the energy right now, we're really concerned about the mass, says that you have to have the same number of atoms of each element on each side of the equation. And that's because neither matter nor energy is created or destroyed during a chemical reaction. We'll talk a little bit about energy in chemistry. That probably is covered a lot more in physics. So that means when you balance, you got to make sure you have the same number of atoms on each side. That's what we're doing in balancing an equation. And if you do that, the mass of your reactants should be equal to the mass of your products also. The state of matter should be indicated for each reactant and each product, and we're going to talk about some of those representations down in the farther in the notes. We'll concentrate on it a little bit during Chem 1, but really that's something you cover more in AP chemistry or college chemistry. So all chemical changes are accompanied by some type of change in energy, a reaction that releases energy. So that means the energy would be a product is going to be an exothermic reaction. And then opposite of that, a reaction that absorbs energy or takes energy. So that means your energy would be a reactant, would be an endothermic reaction. And we'll do a little unit on thermochemistry where we'll concentrate on that. All right, everybody got this? All right, I'm gonna move it up a little bit. All righty, so let's look at some of the symbols that we're gonna be using. I'm sure a lot of these y'all will recognize. A plus sign is just gonna separate two or more reactants or products. My yield arrow, that represents yield. It's not the same thing as equal to, it just shows what the reactants change into in the products. Sometimes you'll have an arrow with two sides or two heads, and that means that it's a reversible reaction. So maybe you build up a lot of product and then it'll reverse and go back to the reactants. A small s in parentheses shows that a reactant or a product is in the solid state. So remember, on your periodic table, anything that's represented in black is going to be a solid. So if I say iron mixes with oxygen. Iron would be a solid. That's like a piece of metal. And then my oxygen, what state would it be in? A gas. So those kind of things you should be able to tell off of there. Also remember, most ionic compounds and the ones that we worry about are also a solid at room temperature. Another way to show that something is a solid, but only if it's a solid as a product, would be an arrow going down. And that means that a precipitate, which I have not been able to spell today on my first try, I don't feel like once, precipitate has, yes, just a down arrow, has been formed. So that's like when you have two, and we'll do this in lab, you have like two clear liquids. They don't have to be like water. One could be a clear blue and a clear red. They just don't have any solid with them. And then when you mix them together, you end up with solid at the bottom. That is a precipitate, and that can be represented with the down arrow. If it's a liquid, it's L in parentheses. If it's in a aqueous solution, an aqueous solution means that something is dissolved in water. So water is your solvent, then it would be AQ. And a lot of reactions occur in water solution. If it is a gaseous reactant or product, it would be represented with a G. And if the gas is produced as a product, you can also represent it with an arrow going up. But once again, that's only on the product side. All right, a triangle represents that heat had to be supplied for that reaction to occur, and that triangle would be drawn over the yield sign. So that's usually some type of endothermic reaction that requires some energy. And then if you have a formula written above or below the yield, that should have a little yield placed in there, a yield sign, that indicates that it is used as a catalyst. And if you remember from biology, catalyst is something that speeds up the reaction, but is not changed or used up. So let's say that I'll make this into a yield. And then if I said something like MnO2, manganese oxide, and it was written above the arrow like that, that would show that it was a catalyst. It's not going to be written as a reactant. It's not going to be written as a product because it hasn't changed. I feel like I left something up there. Oh. MnO2. The last what? I'm sorry, I'm not following you. I'm sorry. Oh, that's an arrow going up. Yes, I'm sorry. All right, let's go back up to the top because I just kind of skimmed over D right there, A, B, C, D. And that's a really important one. So I'm gonna just jump back up there. So it's really important when you're doing these, especially for this unit and our next unit, that you don't forget your Brinkelhoff, your diatomics. And remember, those diatomics are two atoms together when they are alone, not when they're part of a compound, okay? Also, besides diatomics, there are also some polyatomics. So that's not polyatomic ions, polyatomics, and these are atoms that exist as multiples when alone. And so the two that we're going to worry about is sulfur. And it exists as 8 atoms when it's all by itself. Not when it's part of a compound, but when it's all by itself. And the other one is going to be phosphorus, and it exists as 4 atoms when it's all by itself. Let me move that up a little bit if we need to. So I'll rewrite that in case you didn't get it. The two that you need to worry about would be sulfur as S8. You didn't get what? Okay, phosphorus as P4. Let's see, we said they are polyatomics, and they exist as multiple atoms when alone. So if you, when we get to the part where you're given the equation in words and it's sulfur, you should write that sulfur as S8. That's only when it's alone. The same thing with the diatomics. Right. All right, can I move up the Devin? Is that okay? Or you still get it? Mm-hmm. And then a P4. We good? Okay. All right, so on the top of the next page, just to refresh your memory on counting atoms, because that's kind of the whole point of balancing equations. Got to be able to count your atoms. So remember, the subscript is the small number within a formula or a compound, and it tells you the number of atoms in that compound. So that would be, for instance, right here, where I have my 2 with my chlorine. Remember, a subscript only affects what is behind it. So that 2 only affects my chlorine. It doesn't affect the magnesium. Since the magnesium does not have a subscript, then we would just have a 1 atom. Remember, a subscript of 1 is just assumed. And then, like we said, the chlorine has a 2, so that means it's going to have 2 atoms. Same thing here. I have 10, which is SN. It has a subscript of 3, so that means it has 3 atoms. And then my nitrogen has its subscript of 2, so that means it has 2 atoms. And we've done that before, and I know y'all probably done it previous even to here. So coefficients, that's what we're going to use to balance equations. So when we were writing the formulas, which you'll still get to do, have to do, if we were writing the formulas, we were manipulating subscripts. Now we're not going to change the subscripts to balance. We have to worry about the coefficient. So it's a large number in front of a formula or a compound. It tells you the number of molecules that you have if it's the molecular compound, formula units if it's an ionic, or atoms if it's an element, and how many moles of each. So coefficient tells you how many moles you have of each compound or element in that equation. And from here we go to stoichiometry, so we'll be using what's called the mole-to-mole ratio a lot. Remember that when you have a coefficient, it affects everything behind it. So that 3 is going to affect sodium, sulfur, and oxygen. Okay, it's not like the subscript, which just reflects the element that's right in front of it. All right, so if you start counting these, if it has a subscript and a coefficient, then you multiply. So for my sodium, I'm going to say 2 times 3, that would give me 6 atoms of sodium. Sulfur doesn't have a subscript, so we assume it's a 1. So 1 times 3 would give me 3 atoms of sulfur. And finally, my oxygen has a 4. So 4 times 3 would give me 12 atoms of oxygen. If you'll, on that second example, change sodium to calcium. All right, so if we look at that, how many atoms of calcium, of Ca, do we have? 12, exactly. 12 times 4. Now the phosphorus and the oxygen, the P and the 4, because they're in parentheses, they're also affected by that too. So we're going to do subscript times subscript and get you a total, then come back and multiply it by the coefficient. So for my phosphorus, even though it's not written, remember we assume it's a 1. So 1 times 2 is 2, and then 2 times 4 is a total of 8. So how many oxygen would you have? 32, exactly. 4 times 2 would give me my 8, and 8 times 4 would give me my 32. Do not write a coefficient of 1. Just like we don't write a subscript of 1, we don't write a coefficient of 1. It is understood. And if you'll look at your practice, I think back to maybe like the 3rd page, which is actually a key. You'll see that I went through and I tried to strike out all the ones because I had pulled this key just off the internet and they were putting 1s in. Just because there's a blank, that means something has to go there. You should not write a 1. You should just either leave it without a coefficient, even if there is a blank there. All right. So let's start on balancing. We're going to do a couple here, but we're going to mainly do them on the that practice because there's more room on there. So you write your equation using your correct formulas. Today and tomorrow, you're going to be given the formulas. Starting on Friday, you have to write the formulas. So if you did not get nomenclature, if you never got that, you thought it was going to go away, it does not go away. So if you didn't get nomenclature, you're going to need to come in for tutorials on that. Once the formulas are written, you do not change them again. That is not how you balance equations. After you've done that, then you balance the equation, and you're going to want to take an atom inventory first on both sides of the equation, and then you're going to adjust your coefficients to balance the equation. Not going to change your subscripts. All right, so let's kind of look at a couple on here, and then we'll go back, like I said, and do more practice on there. Oh, no practice. All right, so we'll just start with the first one. Good old water being broken down into hydrogen and into oxygen when we look at A. You just have 2 elements on this to worry about, your hydrogen and your oxygen. So I need the same number of atoms on each side of the equation. So on my reactant side, I have 2 hydrogen, and on my product side, I have 2 hydrogen. So hydrogen is nice and balanced. Now, if I look at my oxygen, I have 1 on my reactant side, and I have 2 on my product side. So that one is not balanced. So where am I going to put the coefficient to get that balanced? Reactant side or product side? I have 2 oxygen. Over here, I only have 1. I need them to be the same. Reactant side, exactly. So what's my coefficient going to be? A 2. I'll put my 2 right there. You put your 2 or whatever coefficient you're using in front of the compound or the element you want to change. So it changed my oxygen to 2, but it also changed my hydrogen now to what? 4. So I need to come back on the other side, and what do I need to put right here? A 2. And that's usually how they work. Like you'll get one thing fixed and maybe it messes up something else. So you got to go back and forth and back and forth. Sometimes I'll want to have people, and they'll try to come in and like slip a coefficient down the middle of there because they want to change their oxygen. That is not a thing. You can't do that. Okay. So if I read this now and I use my coefficients, because remember all of them have a coefficient, even if it's an assumed 1, I would say 2 moles of water, because I have a coefficient of 2, decompose, which just means breaks down into, here's my hydrogen, 2 moles of hydrogen gas, and I have an assumed 1 for my oxygen, 1 mole of oxygen gas. That's what my coefficients tell me. Water, I could have given it H2O, a liquid, obviously, in this case. Hydrogen and oxygen, I think we all know they're gases, but if you don't remember, they would be up here red on the periodic table. All right, let's look at one more here and then we'll switch over there to our practice where we have a little bit more room. All right, sometimes you'll have a polyatomic ion. So here I have a polyatomic ion. That's my NO3. And remember, your polyatomic ions are the ones that are down here on your ion sheet. Those ions that are made of more than one element. So if you have a polyatomic ion, you want to keep it as one unit when balancing. So in other words, I'm going to think of this NO3 as just one thing. And since this one is in parentheses, that means I have two nitrates or two NO3s on the reactant side. This NO3 is not in parentheses with the subscript on the outside. So I just have one nitrate group on my product side. All right, so let's try to balance that one and we'll do another example of this on the practice also. So if I start looking here, lead PB, so I have one lead here and one lead there, so that looks good. But like we said, if we think of this nitrate as just one unit because of this subscript of 2 on the outside of the parentheses, I have 2 nitrates and over here, I just have 1 nitrate. So I would need to put a coefficient of 2 right there. When I did that, it changed my nitrate, but it also changed my sodium to 2. So I would need to come back and put a 2 in front of that sodium to get it balanced. All right. If you'll switch over to your practice, we're going to do more examples there because there's a lot more space to work those out. All right. All right, so we'll just do a few here and there. So I'm going to balance these by taking a atom inventory to get them balanced. For some people, balancing equations is very easy. And I will say the more you do your practice, the better you get at it. You get better at it, you get faster at it. So it is one of those things where practice makes perfect. For other people, it's a real struggle. And it all just has to do with how your mind works. Like my mind does not work like 3D. So if you try to explain some 3D thing to me and how it fits together without me having it in my hands, it's not going to happen. So we all have different ways that our brain works. So I'm going to show you this longer method, and some people may need it, some people may not. So I'm just going to draw a line down at my yield arrow to separate my reactants from my products. And then I'm going to list my elements. I have 2 elements, iron and oxygen. And if they're on my reactant side, they got to be on my product side. And I try to keep them in the same order because if not, I'll flip my number or something. So the first thing I'm going to do is I'm going to take an inventory of what I have with the reaction started or before I balance it. So right now I have 1 iron and I have 2 oxygen atoms. And then on my product side, because of my subscripts, I have 3 iron and 4 oxygen. So that's what I'm starting out at. It'll be balanced when all those numbers are equal to each other. So like my number of iron is equal on each side. My number of oxygen are equal on each side. So I'm going to start with my iron. I have 3 as my product and only 1 on my reactant side. So I'm going to go to my lower side. What coefficient do I need to use to get that balanced? A 3. So I'm going to come and put a 3 here. Then I'm going to go down and make my change. So now my iron is good on each side. My oxygen, same thing. 4 here, only 2 here. So what do I need to multiply my 2 by to get me to 4? 2. So that becomes my coefficient there. And then I change that to 4. And there we go. We got a balanced equation. Same number of atoms on each side. All right, why don't y'all give number 2 a try? Start off, do your little inventory, and then see if you can get it balanced. You may not need to do an inventory on that because it's a pretty easy one to balance. So give it a try, and then we'll come back and check it. All right, did anybody get it balanced? When you balanced it, did you need a coefficient in front of the strontium? Huh? What do we need? A 2. Did we need a coefficient in front of the oxygen? Nope. Do we need a coefficient in front of the strontium oxide? What do we need? 2. So if you balanced it, that is your balance equation, and I'll still work through it. So we got strontium, oxygen. So we got 1, 2, 1, 1. So my strontium looks good, but my oxygen doesn't. I have 2 here, and I only have 1 here. So I'm going to go to the smaller side, and I put a 2 in front of the compound that has oxygen. So it changed my oxygen like I wanted it to, but it also changed my strontium. So be sure that you adjust everything, because if not, that might mess you up. So it changed that. So that means I need to come back over and put a 2 in front of there. So I would end up with 2 atoms on that side also. And that's real typical. Like I said, you'll fix one thing and sometimes it messes up something else that already seemed to be good. So you got to kind of work back and forth. All right. Anybody have any questions on that one? All right. I'm going to jump down to number 4, and it's a pretty hard one to balance. Oops. So this type of reaction is called a combustion reaction. And it's between a hydrocarbon. This is your hydrocarbon right here. It's just a compound that's made up of hydrogen and carbon and oxygen. So there's my oxygen. So hydrocarbons are usually different sources of fuel. So a lot of times a combustion reaction is used as an exothermic reaction, produces energy that we then capture and use some way. When you balance these, you want to start with your carbon first, hydrogen second, and oxygen third. And the reason you want to do your oxygen at the very last, if you notice, I have oxygen here and oxygen here. I have oxygen from 2 compounds. So that's why you want to leave it to the last. You hope that it just takes care of itself while you're balancing the other ones and you don't have to deal with it. All right, so I'm just going to start like we do. I have 8 carbon. Hydrogen, I have 18. Oxygen, 2. And on this side, 1 carbon. Hydrogen, I have 2. And how many oxygen do I have? 3. All right, let's get our brains going because y'all have to do simple multiplication in your heads. It has not been a good process so far today. All right, so I'm going to start off. Carbon, I'm going to do that one first. I have 8. And on my product side, I only have 1. So I'm going to put my 8 in front of the compound that has a carbon. So that changed my carbon to 8. And now if I look at my oxygen, 8 times 2 is 16. And I have another one here for a total of 17. Still not going to mess with that one. I'm going to hope when I do the hydrogen, it works out. I have 18 hydrogen on my reactant side and only 2 on my product side. So what coefficient do I need to put in front of my water? 9. 9 times 2 is 18. But my big question is how many oxygen I have. So 8 times 2 is 16 there, plus another 9 for a total of 25. So that's what I have at this point. Nope. I wish it was because it would make it easier. Because 16, 8 times 2 is 16. And then plus 9, it would have to be plus 10 to give me 26. Where do you see your extra 1 at? Here's my 8 times 2 is 16, right? And then on my other one, 9, and that one oxygen doesn't have a coefficient, so that just gives me my 9. Oh. I wish it was even because it would be easier. What's the problem with this 25? It's an odd number. And is there any way that I put any coefficient in front of that oxygen to get an odd number? Nope. So this is a little trick. When you have an odd number that you need to be even, we're going to multiply all coefficients by 2. All right, I'm going to leave out oxygen because I never got it balanced. So I'm going to deal with my other ones. So 1 times 2 would give me 2 here. This is where my mind is a little. 8 times 2 would give me 16, and 9 times 2 would give me 18. Does that all sound good right now? All right, so now let's recalculate. 8 times 2 is 16. 18 times 2 is how many? 36. All right, I'm still just at 2 oxygen. All right, now I'm gonna come over to this side. I put a 16 in front of my carbon dioxide, so that gave me 16 carbon. I put a 18 in front of my water, so that gave me 36. So now the big question is my oxygen. All right, here, 16 times 2 would be 32, plus another 18 would give me 50. Now a nice even number. Split that in half, and what coefficient do I need to put in front of the oxygen? 25. So a little bit longer one, but that doesn't always have to be done with combustion reactions. Sometimes they all work out really nice and it's less trouble. But sometimes you have to do that, or there are other kinds. But just remember that if you get stuck with an odd number that you need to be even, try that little trick. And like I said, the more that you work on the balancing, the more you see those kind of odd little things. All right, I want to do one more. If you'll go down to number 9. And it'll seem really easy after we did that one. All right, so if I look at number 9, start just like I do. So I got barium, Cl, chlorine, K, potassium, but this IO3, that is iodate, which is a polyatomic ion. So I'm going to keep that together instead of separating it into more elements. And then I'm just going to come and do the same thing over here. My IO3 is also over here. All right, so let's do a quick count. Barium, I have 1. Chlorine has a subscript of 2. Potassium, 1. For my iodate, if I think of that whole thing as 1 unit, how many of them do I have? Just 1. Okay. Now let's go to this side. Barium right here is 1. Same thing, my iodate, here's my iodate. How many do I have on my product side? 2, because it's in parentheses with the coefficient on the outside. And then 1 potassium and 1 chlorine. All right. So now let's see, barium looks good. My Chlorine is off. I need 2, so I'm going to come and put a 2 in front of the compound that has chlorine. So that changed my chlorine. But don't forget, it also changed your potassium. So now I got my potassium 2 over here and only 1 over here. So what do I need to put in front of my compound that has potassium? 2. So that changed my potassium to 2. And now how many iodate group do I have? 2. And that is what I wanted. And that's usually how it is. If you have a bunch of elements, like you'll get some of them balanced and everything else just kind of seems to get fixed at the end. All right, so we're going to continue with that tomorrow, just the balancing part. The actual quiz over balancing isn't till Monday. The quiz on Friday is over the notes. It's multiple choice. You may have to recognize a balanced equation, but you're not going to have to go through the balancing process until Monday. That gives you a little bit more time to work on your practice.
What's the quiz? What? No, it's still like
But I said to y'all, yes, we have a multiple choice quiz over the notes that we've covered on Friday. Yeah, but not, you don't have to actually balance an equation. You may have to recognize one, but you don't have to balance it. Okay, this is the time of the year where you start having a lot of things that you're out for several days, like a baseball tournament, a softball tournament, a soccer tournament, whatever stuff. Don't forget, if you're out, you got to make arrangements with me ahead of time. Okay, so if we have a quiz, so you won't get a 0 and then end up with at the highest of 70. Y'all have a good day. Okay, I can get that point. Hold on 1 second. I'll put it right back up here. I'm gonna put it perfect time and I'll put it right back up here. Oh, all right, there y'all go. And I think I'm gonna do an attendance thing for y'all just in case.
It's a 4 to 6 weeks, right?
Yeah, yes. Reason sports. Just gonna stop recording real quick, because if not, I'll forget.